I love it when companies are doing something that is different, something that nobody else is doing, and they carve out their own little niche, where if you have a specific set of requirements, then this is it. This is the best solution to that. And the BCN3D Sigma D25 that we're going to review today is exactly that. It's a large printer from a reputable company, and it's got dual extrusion with two independent tool heads that each run on their own x-axis. Oh, and did I mention how freaking large this printer is? Here's a Prusa Mini for comparison. I mean, look at that. But as with all niche products, there are some trade-offs you're gonna have to make. Thankfully, with the Sigma, they're not that severe, well, most of them. And I'll walk you through those right after a message from today's sponsor. This video is sponsored by JLC PCB. They produce your PCB designs even when you just need a couple of boards. And if you want to, they can also populate them with SMD components and ship you a finished working board. I've already ordered from them a couple of times and they've always delivered top-notch quality at super reasonable prices. They've now added a new board color that you can choose, the classic shade of purple. And yes, you can also get them with gold-plated pads to complete the look. Check out JLC PCB at the link in the description below. Let's start with a disclosure. BCN3D sent me this printer for this review. I do not get to keep it and no money changed hands. And as always, BCN3D did not get any influence on this review whatsoever. So, who are BCN3D and what is the Sigma D25? So, BCN3D are a company from Spain whose whole thing is making what they call IDEX printers, independent dual extruder machines. So that means, unlike say on an Ultimaker, where you're carrying around two hot ends on a shared toolhead, on an IDEX printer, usually you're only ever moving one over your print space and the other one is parked off to the side. The main advantage is that you mostly don't need to worry about the idle hot end dribbling out little bits of molten filament over your print after the printer has switched from one to the other. And of course, dual extrusion lets you do either multicolor prints or multi-material prints, where, for example, I don't have any flexibles here, but where, for example, you print a flexible hinge into an otherwise rigid part, or you can stick with a single material for your print and then use the second extruder to print support material that is either easy to peel off or can be dissolved away with water or other solvents after the print has finished. But because the Sigma has those two completely independent extruders, it can also run in duplication or in mirror mode, where the movement of one tool head follows the other and you can simultaneously print the same part twice, either as a symmetrical pair or as a straight copy. I don't think this is what you specifically buy a Sigma for, but it's a nice bonus feature that you basically get for free because of the way the printer is set up. But let's get the specs out of the way first. The Sigma D25 is basically BCN3D's lowest end model, but they're using a shared platform for their entire lineup. Above the Sigma, you have a bunch of different versions of the Epsilon, which adds things like a complete enclosure, filament storage underneath the printer, or a longer Z-axis. But the basic components all seem to be the same. So, two toolheads. The hot ends are made by E3D, and they're basically V6s with a weird shape. The extruders on the back use Bondtech dual drive gears, and it's all tied together in a large dual bone setup. The extruder specifically, and I don't know how much the hot ends also played into this, but that was the biggest hindrance in the old Sigma R17, so it's good to see those parts upgraded. Yes, I do still have the R17, and it's been through a lot. These two machines are still remarkably similar though. But now the D25 has a massive 420 by 300 millimeter usable build area, but it only goes 200 millimeters tall, which I think is great. Sure, making the Z-axis longer is usually the cheapest way of, extending the printer's build volume. But personally, I almost never print parts that are taller than, 10 centimeters or so, except for these, of course. And I think for most practical applications, it's going to be similar. I mean, here you're extending the print space where you get the most strength out of your parts in X and Y instead of, relying on layer adhesion when printing parts upright. It does, however, make the Sigma D25 an incredibly chunky board. Like I can't even wrap my arms around it. And it's almost impossible to move around this thing on your own. And, you know, of course, it also does take up quite a bit of surface space. But I looked through what alternatives there are to the Sigma D25. Like, just starting at the size, a printer with a 420mm wide usable print space. Some of those exist, yeah, but I've not found one that does dual extrusion too, and of course isn't a $100,000 Stratus or something. I thought, you know, maybe the Ultimaker S5 was a contender because it's Ultimaker's larger printer, but that one only has a 300 by 240mm build area. That's not that large. So when I tell you the D25 is around $4,000, links in the description, that's actually not expensive at all for this machine. Yes, I know, it's a lot of money for a 3D printer, but you also get a lot of 3D printer for it. You know, it's even more impressive once you consider how small of a company, comparatively, BCN3D are. They're not shipping millions of printers a year, but honestly, I think the amount of development that went into their printer lineup, including the Sigma, is way more than what those cheaper mass market machines are seeing. So let's get to the important bit. How does the Sigma D25 print? Really well, sometimes. So getting test parts out of the D25 took a bit longer than usual. It's a large printer, right? So trying to test with prints that make use of that space just results in long print times that you have to wait for. Using a realistic model to use up most of the build volume in dual material mode takes something like 5 days. But also, I was trying to figure out why some prints, like, I don't know, like this one, came out beautifully, or that one, and others looked like absolute garbage. Like, if it prints like this all the time, perfect, amazing, fantastic. But if all it was producing was prints like this, then the D25 would be absolutely worthless. But it was doing both. These are both prints from the D25 back to back. So BCN3D give you a modified version of Ultimaker's Cura to use with your printer. Usually I'd say, hey, instead of forking stuff or trying to program your own slicer, just submit your profiles to the devs of Cura, Prusa Slicer, etc. and just use that. There's no need to maintain your own. But this is one of those few cases where forking does make sense. You have the extra duplication and mirror print modes that probably would be hard to get working nicely with the preview and all that in regular Cura or Prusa Slicer. Plus, BCN3D do regular updates, and the Sigma R17 ran with Cura 15.04 basically. Then the slicer, when I started printing with the D25, was based on the newer Cura 3, I think. And halfway through testing, BCN3D released their newest slicer, Stratus 1.0, based on the newest Cura 4. So all good there. Stratus works great. I mean, it's a fully featured Cura with just a couple of modifications to make it work better with the BCN3D machines. But it still didn't explain why these prints looked so bad and these looked so good. Until I started digging through the profiles, because this looked like it was just the infill speed and acceleration settings cranked up way too high. And it was, but only in the PLA profile. These nicer prints are P2G. You don't expect there to be such a drastically different profile for just a different type of material. So yeah, that is definitely an oversight on BCN3D's side. And it must have been a while that it's been in their slicers, since I saw the difference between PLA and PTG prints, both in the old BCN3D Cura and in the new Stratus. Hopefully that gets updated with Stratus 1.0.1, because, I mean, the Sigma is capable of printing really well. You know, it almost looks like whoever set up the PLA profiles already tried to hide the issue from those insane accelerations, because by default, the Sigma D25 prints with 4 solid shells instead of your normal 2. You know, it doesn't really hide all that much, but it uses so much more filament. Let me just weigh these real quick. So slightly modified profile with 2 shells and horrible print quality, 170 grams, and then 4 shells, 246 grams for the same part. It doesn't really hide much, but it uses so much more filament, unnecessarily in most cases. Speaking of filament, the Sigma uses 2.85mm. For those of you who are new to this whole 3D printing thing, that's an empty spool. 2.85 or 3mm filament, back then known as welding rod, that's what 3D printers started out on before most of them moved to 1.75, which is easier to drive with an extruder, can be melted faster in the hot end, and is generally easier to handle because especially with PLA, the smaller stuff is just less rigid and stiff. The Sigma R17 notoriously had problems where PLA would break inside the filament guide that goes through the bottom and comes out the back and then goes back up over the printer, where PLA filament would often break inside that filament guide if it sat unused for a couple of days, and that would make for some really stringy parts because, retractions just wouldn't work if your filament is broken. Out of the probably hundreds of filament spools I had 4-ish. That's another empty spool in there. 2.85mm ones, and I had to order extra PTG, which is loaded in the printer right now, just to use the Sigma. But the PLA filaments, all snapped inside the D25 as well. I really wish they would move to 1.75mm. Just because Ultimaker is still using 2.85 doesn't mean that BCN3D has to as well. And obviously a lot of the things that BCN3D do are inspired by what Ultimaker does. One of those is BCN3D Cloud, which honestly I've not used much, but the Sigma D25 has an Ethernet port, and I guess you can also plug in a Wi-Fi dongle and use that, and then monitor and upload prints through a browser. There's no webcam in here, so you don't get that much information during a print. However, where I did run into the BCN3D Cloud stuff was during the initial setup, and you can watch the live stream, I think up here, I'll link it. The printer forces you to create a cloud account and register the printer's serial number to unlock that first run wizard. I guess you can do the initial calibration using the individual assistants as well, but that's not really how it's meant to be used. And then also, after every print, the machine asks you to rate how it came out, even when you've not hooked up the printer to the internet at all. To me, that was just a nuisance. I guess you'd be able to see statistics of how your printer is performing in the cloud service and possibly BCN3D, get feedback on how well their cure profiles work, but I can't imagine anyone standing there and going, oh, is this a 3-star or a 4-star print? No, you just want to skip the next screen, so you just end up punching in whatever. I doubt the data out of that would be useful. I realize we've not talked much about the hardware of the Sigma yet, and I think that's pretty cool when, the printer is not just a set of aluminum profiles that runs the same software as everyone else, and you actually get to talk about stuff that's unique to this machine. So, anyways, let's get that covered. We did talk about the Bondtech gear extruders and the E3D made hot ends, but one thing to note is that this entire machine is incredibly slow. I don't know how else to put it. The base print speed for the nicer PTG profiles is 30mm a second, and even slower for details. Even with the PLA profile, these two took 24 and 15 hours to complete. I feel like, the machine itself could handle a good bit more speed, but one of the solutions from BCN3D is larger nozzles. But not just swapping in larger nozzles, but a completely new hot end that has a larger nozzle. They sent me this set of hot ends once for the Sigma R17. I think it's still compatible, but yeah, you're not supposed to swap the nozzle itself, but instead the entire hot end. This is 6 complete hot ends. And I get it. Ultimaker are doing it that way too. And to be fair, there is a lot less than can go wrong when you undo the 2 screws on top of the hot end and you undo the 1 connector that plugs everything in, than if you actually had to swap a nozzle and then hot tighten the new one without bending the heat break and apply the correct torque. But yeah, it does seem a bit wasteful. But not only is print speed slow, but also the heat up times. It takes almost half an hour to get the bed up to temperature for printing PTG. It's a silicone heater on an aluminum plate with a glass sheet over top. This is a lot better than the massive air gap that was on the Sigma R17, but there's an issue where the inserts on the aluminum are still sticking out and creating a bit of an air gap as well as bending the glass a bit. First of all, this should be a flex plate, especially on a printer this big, and also I was having some real trouble keeping this thing consistently level. Sure, the calibration wizard that tells you how far to turn the adjustment knobs up front here on the bed so that you get the bed perfectly level, yeah, that is still absolutely fantastic and it works great. But I had to run it basically before every print to get especially larger parts to reliably stick. Sometimes the nozzle was digging through the layer of glue stick on the bed. Sometimes half of the first layer would be way too high, but it was rarely consistent. You can see it with the brim on here, like, one half is perfect. The other one was printed up so high that this is not much of a brim anymore. Maybe it has something to do with the way that the bed structure is mounted. It's using a pair of what looks like M3 screws threaded into the back of a plastic Delrin block in the back here. In any case, it's quite wobbly despite, oh yeah, this side's pretty loose. It's quite wobbly despite being a rather bulky construction. Bed probing happens with a micro switch on either tool head. The left one probes the left edge, the right one the right edge, and both probe the front. But unfortunately, that's not being used for mesh bed leveling. It's just for the calibration assistant. Maybe adding that layer of auto mesh leveling on top of the pretty good mechanical leveling would solve that first layer problem I was having with this Sigma D25. It's overall a printer that doesn't cheap out on parts. You've got genuine high wind rails on X and Y, and if you look down into the electronic compartment, it's basically textbook wiring in here. It uses two Meanwell power supplies. One is dedicated to the heated bed, the other is for the rest of the printer. They've got a Linux board in here that does networking and controls the touchscreen and the mainboard, which interestingly has no motor drivers on it, because those are all right next to the stepper motors they're driving. That's a great solution to reduce wiring length of the switched motor wires, which helps with electromagnetic compatibility and motor performance. Though maybe I wouldn't have used an SSR to switch the 24-volt heated bed, as an SSR tends to waste quite a bit of power, and a decent MOSFET would probably have cut down heat up times quite a bit. But hey, it works. Now, the touchscreen on the front of the printer is beautiful. It's large, it's super bright, and it does have adjustable brightness, and it's one of the few touchscreen interfaces that work really well. Maybe that's because it doesn't actually do many of the more advanced features like being able to set a temperature manually on the hot ends, and yeah, in some edge cases, using, for example, the assistance for swapping filament can be a bit counterintuitive because it forces you into that workflow, but overall, it's a pretty polished experience. Though on the topic of filament swapping, that's actually one of the spots where you do get to see a bit of roughness still. First of all, when unloading filament, the two tool heads are called left and right. But when loading, you can see it's a totally different UI experience, and now they're being called 1 and 2. And also, I had some trouble loading the left extruder once when I had PLA break inside the feed tube, because as it turns out, it wasn't actually feeding only the left extruder, but every time I pressed feed more filament, it would switch between feeding the left and the right, and then the left, and so on. That still needs a bit of work. Also, I wish they made use of that beautiful color touchscreen a bit more. For example, with print previews, or even just telling you which materials a part was sliced for in the overview list. It does stop you from printing with the wrong materials loaded, so that's nice. The filament system is pretty slick, with options to mount your spools either inside the machine if you only have access to it from the front, or on the back, and then you've got this multiplexer bit that allows you to feed filament into the same extruder from either path. You know what I would love to see though, since Sigma already has a pair of filament sensors? Continuous printing for single material prints, where you load two identical spools of filament and then it automatically switches over to the other one when one is empty. If you look at the printer close up, you can very clearly tell that this is more on the side of being a handcrafted low volume machine. First of all, everything on this machine is very simple. It's either sheet metal parts, laser cut acrylic, or simple CNC machined blocks. And some spots, like the frame, are a bit rough looking, with swarf from the laser cutting still being visible under the powder coat. Or on this particular machine, two of the frame panels actually starting to open up to a gap. They do make a great job of making the Sigma look like a polished professional machine, but there's no denying that it still does have a bit of that low volume artisan flair to it. Because it is a mostly metal frame with no plastic bits on the motion system, it is also a rather loud machine. Sure, it's got dynamic drivers, but every bit of noise and vibration is transferred straight through the entire frame. The fact that they've got a pair of fairly noisy always-on fans kind of doesn't matter at that point, but yeah, it's not a particularly smooth sounding or even a silent machine. Overall, I find it fascinating how much there is to say about a machine when it's not just another cookie cutter recipe. And again, my hat comes off for BCN3D doing so many things on this printer that are innovative and different and unique. Like I said, if you need the capabilities of this printer, there's nothing else that fits the bill, especially not for the price. Sure, if you just plan on running this in duplication mode, just get a pair of Prusa's for half the price. But for large format and dual extrusion prints, this is it. The first layer issues and the honestly just straight up bad PLA profiles, they are a bit of a showstopper for me, but I'm sure the profiles are going to get updated and the situation with the bed might be a fluke on this very printer only. In any case, the Sigma series does hold a very special place in my heart simply because it is such a unique printer. And you know who else holds a special place in my heart? All of you who are supporting the channel through Patreon and YouTube memberships. Seriously, thank you so much for allowing me to keep this channel independent and on its own 2 feet. If you want to find out more about the Patreon perks, check out the link in the video description below. Also down there are the links where you can buy the Sigma D25 if you're interested, and when you run across the subscribe and thumbs up buttons, make sure you give those a tickle as well. As always, thank you for watching, keep on making, and we'll see you in the next one.